तो आज के दो क्वेश्चंस बच्चों, two questions from coordinate geometry. I found them to be really good, really interesting, and I believe जिन बच्चों से हो गए होंगे उन्हें अच्छा लगा होगा. जिन जो बच्चे solution देखेंगे, they will definitely gain so many things here. First question is, a parabola touches the angle bisector of these two lines. Okay, so the lines are, so first question, the lines are x plus 2y plus 3 equal to 0. Okay, and another one is 2x plus y plus 3 equal to 0. If I find their point of intersection, so you can easily do it. It's -1 comma -1 बच्चों. Okay, now the angle bisector, see, quickly find the angle bisector. So you can easily find their angle bisectors. How? We know it's x plus 2y plus 3 upon root 5, of course, and this is equal to plus minus times 2x plus y plus 3 upon root 5. When you solve them, see, as I solved this question today itself only, so I remember it. So one is x is equal to y, and another one is x plus y plus 2 equal to 0. Okay, so these are two angle bisectors, and never forget that angle bisectors are always perpendicular to each other. So situation क्या है बच्चों, देखिए situation ये है कि एक है आपका ये पॉइंट -1 कॉमा -1, यहाँ से ये जो ऑफ कोर्स जिस पॉइंट पे ये लाइंस इंटरसेक्ट कर रही हैं, दैट्स अ कॉमन पॉइंट फॉर दीज टू लाइंस ऑल्सो. और so यहाँ से देयर आर टू टेंजेंट्स, दे आर परपेंडिकुलर टू ईच अदर, and a parabola touches one tangent at 1 comma 1. So of course it has to be on this line, y is equal to x line at 1 comma 1. I'm calling it as point A, and another one at 0 comma -2. It's on the other line, which is x plus y plus 2 equal to 0. Okay, तो मान लेते हैं कुछ ऐसा इस प्रकार का कोई पैराबोला आपको दिख रहा होगा, something like this. Okay, तो आपको लग रहा हो ये intersect कर गया. So if I can correct it, just a minute. कुछ इस प्रकार से. Okay, so मान लेते हैं the parabola looks like this. Fine. Now see, the question is, first thing we have to find its focus, and then can we find its axis, directrix, vertex, everything. So it's really an interesting one. See, since the tangents are perpendicular, so the line segment joining points A and B, the points of contact, that is the chord of contact with respect to the point P -1 comma -1 has to be a focal chord, isn't that? And of course this point should lie on the directrix, because from the point on the directrix only you can have perpendicular tangents to the parabola, or from the like to any conic it should be the on the director circle, and for parabola director circle is its directrix only. Okay, so it lie on the directrix. Okay, so now we have to find its focus. Fine, I said let the focus be alpha comma beta, need not be the midpoint, rather it won't be the midpoint until unless it is the latus rectum. AB is the latus rectum. So though it looks like to be a midpoint, definitely I'm not assuming it to be the midpoint. Okay, now see, how will you find? There's a very interesting property, if you remember it. The property is segment of the tangent between its point of contact and the directrix always subtends right angle at the focus. I'm repeating, segment of the tangent between its point of contact and the directrix. So this segment AP of the tangent subtends a right angle at the focus, and that's it. Okay, so you have two relations here bachcho, which two? One is like slope of AF, so slope of, just a minute, yeah, slope of AF into slope of PF is equal to -1, and F lie on the line AB. So let's do it quickly. So F lie on the line AB. AB is 2 minus 1 upon 0 minus 1. Y, it's 0 comma -2, right? This point is 0 comma -2. Okay, so y plus 2 is equal to 3 upon it's 1, isn't that, and x. So it's y is equal to 3x minus 2. So alpha beta lie on it, so beta is equal to 3 alpha minus 2. That's one relation. and as I said, and the relation is of the slope, so it's like AF is 1 minus beta, so it's 1 minus beta upon 1 minus alpha. Similarly, it's beta plus 1 upon alpha plus 1 is equal to minus 1. So it's 1 minus beta square is equal to alpha square minus 1. So it's alpha square plus beta square is equal to 2. Now put value of beta from here to here, solve it, you get alpha and beta. So put beta here, so alpha square plus 9 alpha square plus 4 minus 12 alpha is equal to 2. So this is 10 alpha square minus 10 alpha plus 2 equal to 0. So it's 5 alpha square minus 6 alpha plus 1 equal to 0. You can use middle term split method to solve it. So you get alpha as 1 by 5 or alpha as 1. Now, of course, as I can see, alpha, can it be 1? See, if alpha gets equal to 1, that means A and F both lie on the same vertical line. And in that case, the B has to be on the same vertical line. Okay, so that's not the possibility. So that means I will say alpha has to be 1 by 5. So once alpha is 1 by 5, you get beta as 3 by 5 minus 2 is minus 7 by 5 if I am correct. So we got focus here बच्चों. तो यहाँ से हमारा focus आता है which is 1 by 5 comma minus 7 by 5. That's one thing. Now how to get its axis? So it's AX, IS, axis, directrix and vertex, everything. See, for that I will say one result. See, today itself I realized that it can be a result, and the result is if you draw tangents to the parabola. See, while trying to get, see, I was thinking question was just this much only. Okay, you have to find the focus, but since with the discussion with my students, we had that discussion because I was of the opinion that there has to be a unique parabola, and if it's a unique parabola, we must get its equation. So I was trying to get its equation, and in that process I realized if you draw tangent from any point on the directrix, that means if you draw perpendicular tangents and you draw normal to the tangents, of course, at the point of contact, so it's a rectangle, and the property of rectangle says that diagonals bisect each other. Then see, then what I realized, that these 2 points, which 2 point, the point on the directrix from where you are drawing the tangent, and the point of intersection of normal at the points of contact, the line joining these 2 points is parallel to the axis of parabola, parallel to the axis of parabola. And we know from the property of parallelogram, diagonals bisect each other. Now let's come back to this figure. So if I draw here, just a minute, normals, if I draw normals here, okay, so ABPQ, now that's a rectangle. So APBQ is a rectangle. Now that means line joining PQ. So here, let me write it here only, just a minute. So here, PQ is parallel to the axis of parabola. Okay, so can we get Q? Answer is yes. How? Because we have midpoint of M. So we have the intersection of the diagonals, and I'm calling it as M. So M point is 1 comma 1 by 2 minus 1 by 2. Now using it, you can get Q. How? So let me take it here. So P is minus 1 comma minus 1. This is Q, let's say alpha comma beta, and this is M, which is half comma minus half. Okay, so this is alpha minus 1 by 2 is half, so definitely alpha is, I suppose it's 2, yeah, and beta minus 1 by 2 is minus half, so definitely beta is 0. So this is 2 comma 0. That's the other point. Okay, so now see, we have Q. Now do we have, see, we didn't need it, but still chali, do we have slope of PM? Of course we have slope of PM, or this line PQ. How much is it? So it's 1 upon 3. So that's the slope of the line PM here. So once you have the slope, we have the equation of axis. What is it? So equation of axis passing through the focus. So y plus 7 by 5 is equal to slope times x minus 1 by 5. That's give the axis. Once you have the axis, you have A also. See, how will you find the lattice rectum length? Lattice rectum length, for that, again, you can use this property that segments of the focal chords. I'm writing it here. AF semi-lattice rectum. That is half the length of lattice rectum. And BF are in, what's the property, bachcho? And BF are in harmonic progression. You have length of AF, you have length of BF, you can find, and semi-lattice rectum is the harmonic mean of AF and BF. You can find semi-lattice rectum, hence the length of the lattice rectum. Okay, so now you have focus, you have the equation of axis. So you know, from focus at a distance of like half, 1/4 of the lattice rectum at a distance of A on the axis towards the directrix. See, you know in which direction is the directrix. Towards the directrix is your vertex. Okay, and once you have the axis perpendicular to the axis passing through this point, of course this point is on the directrix, -1, -1, and perpendicular to the axis is your directrix. So you have everything now. Hence, you can write the equation of parabola, because you have focus, you have directrix, you can write the equation of parabola. So that was really a good question. We use so many properties of parabola. Now let's move to the second one. Consider 3 points ABC on parabola x square minus 6x plus 4y. I'm just removing it. Yeah. So x square minus 6x plus 4y equal to 0. There are, see, it's a vertical parabola. There are 3 points on the parabola A, B and C, such that normals drawn at these 3 points are concurrent. Okay, so normals drawn at these 3 points are concurrent. So I'm assuming this to be C. And then if the triangle formed by these 3 points A, B and C and its centroid. So locus of the centroid. See, if you have ABC as 3 points such that normals drawn at these 3 points are concurrent. This is the point of concurrency of normal. What does that mean? You look it from the other side. Consider this as the point alpha comma beta. 3 normals are drawn from this point to the parabola. ABC are the feet of normal, and we should remember the property that if the triangle is obtained by joining the 3 feet of normal, which normal, which are concurrent at a point. So 3 feet of normal, if you get a triangle by joining their feet, the 3 feet of normal, then its centroid always lie on the axis of the parabola, and that's it. Okay, so locus of centroid, so what will that be? So consider any 3 such points where normals are concurrent. Okay, and locus of centroid is nothing but the axis of parabola. So how to get the axis? So you just complete the square, x minus 3 whole square minus 4 times y something. Now we know if you equate in the equation of parabola, if you equate the perfect square with 0, we get equation of the axis. So x is equal to 3 is the axis of the parabola, and that's the locus of the centroid. But so those were the 2 questions for today.